morning to all aspirants. I, Dr. Safraz Ahmed, will be hosting this session. Today topic, statistical graphic in R software, resource person, Jonali Gogoi. Yesterday, you learned what is R, and Sik explained R is the most popular language in the world of data science. It's heavily used in analyzing data that is both structured and unstructured. This has made R the standard language for performing statistical operation. Thank you, ma'am, for a wonderful lecture which is given by you on yesterday. For today, we are eagerly waiting for another awesome session. Thank you, ma'am. Over to you. So, can you, ma'am, start it now?
Thank you, Dr. Surfres.
Yeah, thank you, ma'am.
Thank you for this. And now today, a very good morning to all of you present over here. Am I audible to all of you?
Yes, ma'am. Yes, it's audible.
Okay,
Yeah.
thank you.
Okay.
A very good morning to all of you present over here. And I welcome to all the participants to my second session, which is based on statistical graphics in R software. So now I'm going to present on this topic. So yesterday I taught about what is R, the basics on R. So this is related to here also statistical graphics in R software. So basically what we do, there are two ways in which the numerical information which can be presented. Okay. So one is, we can say, graphical or diagrammatic representation, and another is your tabular representation. So graphs, charts, maps, pictures, these are falls under the first category. That means we can say graphical or diagrammatic representation. So these are falls in this category: graphs, charts, maps, and pictures. And tabular representation, which expresses the data in the form of tables, and after dividing the variable into various categories. So these graphs, or we can say diagrams, gives a pictorial view to give an idea about the relative importance of various figures. Okay, so this diagrammatic representation is an attractive and effective means for presentation of statistical data, which we are going to take. Okay, and then graphical and diagrammatic representation are popular tools which are used for representing data. These are the basic things which we should know about our graphical techniques, and which I'm going to use this in R software. So I'm preparing these slides for you. This is the introduction I have given here. What is statistical graphics or graphical techniques in the field of statistics? These are a visual way of presenting data which are using with the help of charts and graphs. This is I already told. And there are four main objectives of graphical techniques, which are exploration of content of data set, then structure identification in data, and then checking assumptions in statistical models, and last one is your communication of the results of an analysis. What are how we can say some advantages of this diagrammatic, or we can say graphical representation? These are capable of creating lasting impression in the minds of the viewer. Okay, so and this is very simple to understand for even for a layman, we can say. And it is very essential for conveying statistical information to the general public in a short time. So these are the merits, we can say, or advantages, we can say, for these graphical techniques. So next, here you see graphics with R. There are two kinds of graphical functions. We can say high level function, and another one is your low level function. So these are the important things for graphical techniques. So The high level function which creates a new graph, and low level function which adds elements to an already existing graph. So here I am giving some standard plot functions. This will help you to understand about this. So first you see here, function plot within here it is given bracket, first bracket. Here we are using open and close. So this is plot function, and we can name this plot function as scatter plot and more. That means there are many bar plot, or we can say bar diagram, scatter plot and more we can say here. And for bar plot we can say bar diagram. Okay, so his HIST, this is the second one. This function means when we are going to write this hist function in R, then it will denote histogram. Okay, that means for histogram we are writing as a function hist. Then for box plot, this is box and whiskers plot. For this we are writing box plot in case of our R software. And then strip chart, this is same as strip chart. Bar plot, here it will come bar diagram. That means these are the name of the plot and these are the functions which we are going to use. And then stem, this is stem and leaf display. Okay, these are the standard plot functions. Then second table I'm going to show you. This is some arguments to plot function. That means what? First one is your standard plot functions. Here I am giving some functions and with the name of the plot. Okay, with the name of the plot, I am giving here the functions, how we can write in our R software. And then here, here you see in table number 2, some arguments to plot function. That means here you see argument is here, second column, and the explanation I have given here for the corresponding argument. Now you see for argument main equal. What is the meaning of this main equal? That means we are going to write the title. Title, that means suppose we are going to draw a diagram, suppose bar diagram or subdivided bar diagram or multiple bar diagram. So just when we are going to draw, when we are going to plot this diagram in our window, then just we are giving there the name of the plot. What is this? What does it mean? Suppose we are going to draw some graphs and we are not giving any name, then how we can understand this is bar diagram, this is a simple bar diagram or multiple bar diagram or subdivided bar diagram. So for this we are using the main equal to, that means the title of the plot, title of the diagram. I think all of you understood this thing. Then XLab. Second one is your XLab. What is this XLab? That means this is the label for x-axis. So it will be more clear when we are going to do examples. I'm giving here some examples. I'm going to explain on those examples. So first you see, just you should know what are these are the basic things to draw a graph, to plot a graph in our software. So that's why I'm giving here in a tabular form. These are the main things, basic things to you should know. So that's why I'm giving here. So what is XLab? This is equal to your label for x-axis, we can say. What does it mean? I'm going to show you later. Then Y-lab, that means level for y-axis. It is given, this is label for y-axis. Then number 4, serial number 4, X-lim. This means what? This X-lim specifies X limits. Okay, which is useful for our multiple plots. And then Y-limit. Number 5, serial number 5, Y-limit. Y-lim, that means this specifies Y limits, which is useful, also useful for your multiple plots. And then number 6, this is type. So what is this type? Type equal to what? This means this is serial number 6, type equal to type of plot. Okay, type of plot, that means what? P for points, L for lines, O for lines through points. Okay, when we are going to draw, then it will be more clear for you. Type of plot is what? P, this stands for points, small p, this is stands for points, L for lines, O for lines through points. Okay. Then PCAs. PCAs, this means what? PCAs means the plot character. P for plot, CH for character. This PCS, serial number 7, PCA is equal to the style of the points. This can be a number between 0 to 20. That means it will be up to 25, but we can generally consider 0 to 20. So plot character is what? We can say plot character or PCAs. This is the standard argument to set the character that will be plotted in a number of R functions. I think all of you understood. Plot character is what? This is the standard argument we can say to set the character that will be plotted in a number of R functions. So here I'm writing 0 to 20, but there are 25 different points. Point symbols are in R. Okay, there are 25 different. That means we can say here you see here I'm giving the numeric value 0 to up to 20. In case of 0, this is a square form, you can say. Then for 1, we can say this is circle. Then for 2, it is already there in Google. You can see from Google also, no problem, because all the symbols I have not given here. So basically what we are using, 1, so this is in circle, and 2, this is triangle, like that we are using. For 3, this is a plus symbol. For 4, this is multiplication symbol, like that. These are given. Okay. So plot character is what we know that this is the standard argument, and we know that there are 25 different 0 to up to 20 is standard, and from 21 then again it will be look like as your circle, triangle, like that. Okay, but those are filled. Okay, so it will be clear again later. Then the default R plot character symbol, this is we consider as 1. That means the default one is your 1. 1 is your circle. Okay, 1 denotes the circle. Okay, which is then we can say empty circle. For 1, this is by default it is circle, and which is your empty circle. Then if we consider plot character is 19, then this say solid circle. First, if 1, then it is this empty circle, and if 19, that one is your solid circle. Then when we use plot character point symbols in R for this making beautiful graphs. Okay, so why we are using this PCH, plot character? These symbols why we are using? For making the graphs beautiful, looking the graphs beautiful. Okay. And then next one, serial number 8, LTY. That means what is the meaning of this? This is equal to the style of the lines plotted. The style of the lines plotted. Which line we are going to plot in our graph, in our window. Then the style of the lines, which is denoted by your LTY equal to. So this is the short form. This is the argument. That means a short form. That means in R, this is the argument, LTY. So what is this? The different line types. We can say these are the different line types. That means the style of the lines. And this line type can be specified by using either text. That means what? Here you see for plot character, we are using here 0 to up to 20, or symbolically we can say this is for 1 your empty circle, for 2 your triangle, empty triangle. So similarly for line types, for different line types, what we are using, we can write in a text, either in text or in a number we can write. Okay, so for LTY, if we write only blank, then it will denote your circle like 0. Okay, and then if 1, that means what? Number we can use here 0 to up to 6 for this line type. Okay, different line types we are using 0 to up to 6, and here if we are going to write these numbers as a text, this will your blank, then solid, then dash, then dotted, then dot dash, and then long dash or two dash we can say. I think all of you know what is dash. Dash symbol, I think all of you know. And then solid, you also know. So for this, we are using 0, 1, 2, 3, 4, 5, 6. Okay, these are we can use as an argument LTY in our R. Then next, LWD. What is this? LWD. That means LWD, this is called your line width. WIDTH, width. Line width, this is called, this is used to specify your line width. Okay, LWD, this is to specify the width of the line. Then CEX, sex, this is called magnification factor. Magnification factor, that means magnifying something. Or we can say the process of being magnified. So these symbols, this argument we are using in our R function. So these are the explanations about the arguments. And here I have given 1 to up to 10. So all of you please try to remember these symbols, this argument when we are going to do, when you are using this in your R. Okay. So next one you see, low level plotting functions. Low level plotting functions, this one you see here, serial number 1 to 5 I have given, and these are the functions and these are the explanations. Nothing else here. Function is what we are writing functions like this, lines within the bracket. Then again, this is your lines. Explanation is, we can say this means lines. AB line, that means what? Line given by intercept and slope. Points, this means the points. Text means the text in the plot. What we are going to write in the plot as a text. Then legend, this is also important. Legend is what? List of symbols. List of symbols. This will be clear later again with the help of example. So these are the things I have given here for high level and low level functions. I have given some standard plot functions, then some argument to plot functions. These are very important. Arguments are very important. These are we are using in our R. And then this is low level plotting functions. So I think all of you understood up to this. And then now you see, these are the objectives of my presentation, today's presentation. So we are considering here simple bar diagram, because I'm going to give here, graphical representation, diagrammatic or graphical representation. So here I consider a simple bar diagram, multiple bar diagram, pie diagram, histogram, line diagram, and scatter. These 6 diagrams I have considered here. Lots of diagrams are there, but I am considering only this, the simple things. And here another one is I want to say here, subdivided bar diagram. I have not given here. I'll tell you later in the last of this presentation. Just you see. So now I'm going to explain about simple bar diagram. What is the simple bar diagram? So now you see. The simple bar diagram consists of a number of bars, each of which is equally spaced from the other. And these bars are drawn in such a way that lengths of the bars are proportional to the values that they represent. The bars may be placed vertically or horizontally. These are the theory. Basically, just I am giving only a simple theory I have giving for you, because who don't know about this, just read this and then you can understand what is simple bar diagram means. So that's why I'm giving. And generally, these vertical bars are used to represent time series data, and while horizontal bars are used to depict data classified by attributes. This is simple thing to know about our simple bar diagram. And now see, just you see, this is the example of simple bar diagram. Now your query will be clear from this example. With the help of example, we can clear our query. Okay. So following data on profits of a bank for 6 years. So data on profits of a bank for 6 years is given here. So here we are considering, just I'm giving example. 2011 to 2016, and then profits in $1 million it is given. So now you see this is called simple bar diagram. So what is the definition? This the bars are drawn in such a way that lengths of the bars are proportional to the values they represent. So here you see these are your profits in million, bank's profit for 6 years it is given. So it is up to, you see here profits in $1 million it is given 20, 25 up to 48. So highest is your 48, okay, in 2016. And here you see years, it is written here in x-axis, it is years, okay, and here in vertical one, that one is your profit in $1 million, okay. So one thing here I am giving this, you see x lab, y lab, level for x-axis, level for y-axis. This is your these things, years and profit, means this is the labels. Now you see 2011 to 2016 is here. So, and what is simple bar diagram? I told you about this function main. It is given main, the title. So the title of the diagram here, simple bar diagram. So I have already done in our console, so that's why I'm just copy and paste here, and this is this will be helpful for you, easier for you to view. So that's why I'm giving here the picture. Now you see years, it is in x-axis, and profit in $1 million is in y-axis. Now you see how we can draw this diagram. This is only the question is here, and I am giving you the diagram, but how we can draw in R, how we can draw in R. So these are the codings. These are the codings I have given here because it will be helpful for you to practice later. Okay, so that's why I'm giving all the commands. This is called your general R command for drawing simple bar diagram. This is the general R command, and these commands are your commands are your bar diagram for this data, for this given data. Okay, so general one I am given here, and also this is the second one is the R command for drawing simple bar diagram for the given data. On the basis of this data, I am giving this command, and this is your general R command. So how we can do? Just you type years up to days, and then profit, then bar plot. So what are the meaning of this? Just you see X lab, years, names dot, this is argument. Okay, argument we are considering, what argument we are considering here. Y lab equal to profit in $1 million. So that's why it is coming in the diagram like this, profit in $1 million in Y lab, then X lab is your years, and then main is your simple bar diagram. So this is, you know, and here it is coming in a box because I am giving here box. Here it is in general R command, it is not given box. You can add here box, or if you don't want to give box, then it's okay, no problem, because if you are not giving here this box within the bracket, then it will not come like as a box. Simply these things will come, only the X and Y axis, and then the bars will come. Okay, if we are not putting not giving the command box. Okay, so now you see this is the general R command. Bar plot, just you try to understand from here. Okay, just try to understand from here. This is the general R command for drawing our simple bar diagram. So bar plot, this is frequency. Only here I'm giving years and profit. These are the data. These are our with the help of our example, what we are considering our example. These are the data. That's why we are writing here years and profit. But here only the command is, you see, bar plot, then within the bracket frequency, comma, then names dot argument. So here what is frequency? Means profit, and profit we are means here you see these are the years and these are the profits. So these are the frequencies. Okay, so that's why here we are writing profit, because here we are, what you are giving your name, then this should be only here. Okay, if you are giving your PROFIT profit, then here also PROFIT profit. So this is your frequency. Then Years, names and argument. What? Names and argument, that means what argument I am giving here? So years. So years is your 11 to 2011 to up to 2016. And now you see here, then X lab, this is I have already told, years, then Y lab, this is your profit in $1 million, and then main, this is equal to simple bar diagram. If you put here main in $1 million, then this dollar symbol, then it will come also here, the dollar symbol, no problem. Okay, here I'm writing dollars. If you just if you want to give this, no problem. And then main, this is simple bar diagram. We are going to plot simple bar diagram, so that's why we are writing here the title is your simple bar diagram. Okay, and then box. So this will come. Now you see here color, COL, that means the color of the bars, but I'm not using here COL. And here I'm not, you see in this, command, our command, I'm not using color here. Then border, color of the bar borders. That means border means what? This border, we can color it. Okay, and we can give the bar color also. So, but here I'm not using in this command, not using here, not writing here column COL equal to color of the bars, then border color of the bars. This is depends on you. LTY, this is, you know, line type. This is I've already told. One is your solid line. One means your solid line. So it will we are considering here one. Now you see this is this example. This diagram is only for on the basis of this command. Okay. Now you see next. If you want a colorful bar diagram, so these commands are for this diagram. Now you see years and profits are there, then bar plot, or everything is there. But here what we are doing, column, color of the bars. So only color orange I have given, so this color will come. Okay, and if this is no need to write in red. Okay, just to point out here, that's why I'm giving here red color, COL equal to orange within inverted comma orange. I'm giving a red color to point out this. And here you see, if you here if we write border, that means border equal to color of the bar borders, then here it will come also the border color of the bar borders. Okay, so this is a means when you want a colorful bar diagram, then we can change like this. Nothing else. With the help of your general command, just you add color of the bars, and if you need the border color, then you just add color of the border equal to color of the bar borders. So this is simple. I think all of you understood up to this. And then again, next you see, if you want a colorful and labeled bar diagram, okay, so here only the bar colors are same, orange, all are orange. Okay, so all are orange. Here we are, I'm giving here only the orange color. If you choose blue, then it will come as a blue. If you choose this is green, then it will come as a green. Now you see, here what we are doing, years and profits are there, then bar plot, profit, then names dot argument, years, then X lab, that means the level of our x-axis. So this is years, Y lab, level of our y-axis. This is equal to profit in $1 million. And now you see color. See, this is within the bracket, you just write how many bars are there here. In our question, this is for 6 years, 6 bars. So just you write here 6 colors: orange, green, yellow. You choose this is what you need. Just you give by your way what you want, which color you want. Then just you write here. Then I'm writing here orange, green, yellow, purple, red, and blue. So that's why it is coming. And then main is your simple bar diagram. Okay, this is within the box. I am giving here within the box. So that's why box, then within box, then bracket we are using. Okay, just you see, I'm going to do here, just copy these years. Just you see, just I'm going to show you in our, this will come error, unexpected input in years, this is equal to this. That means my, just you use up arrow key and just you change this comma, these are not in R, so this is inverted comma, this is just you correct it here till different. I don't know why this is coming differently here, so I have to change this one. Just we are using inverted comma and then it will come correctly. Just to see. 2012. You have to write, but I am copying from, because already I wrote in my slides. That's why. Now you see it is correct. Then again you go from here. Just I'm going to copy from here. Just profit, copy. Then you see here, paste. Okay, this is also correct. That's why it is coming like this. And then next one from bar plot. This is within one line. Here also I think error. Yes, here also error, because what, unexpected input in bar plot. Okay, for this inverted comma, I don't know why my computer is like this, so I have to change here again using the inverted comma. To change here blue for blue, then red, purple, to change here, then for green, just you correct it, then orange, it's okay. And then for this also $, yes. It is okay. So now just hit enter, start taking cursor here, then enter, so it will come. Okay, here I'm not writing, here you see here box is written, I'm not giving here box. Okay, so that's why this is coming like this. And if we write here box, then, oh sorry, here, just you click on this and then box, so it will come this. I think you can understand the difference. It will come as like as box, within the box. Okay, this simple bar diagram. I think all of you have clear on this simple bar diagram. Okay, so
Yes,
we move to our next one. Multiple bar diagram. So what is multiple bar diagram? In multiple bar diagram, 2 or more sets of numerical information under various categories. That means we are using more than one. We are using here multiple bar diagrams, more than one. Okay, so 2 or more sets of numerical information under various category, or we can say these are classes which can be presented. And here the bars corresponding to each set are differently shaded or colored, and facilitates comparison between more than one interrelated phenomena. Okay, now you see, this is the example. Following data on import and export of a country for 6 years, and import and export, this is given values in dollars. Okay, so here you see this is the example, years imports and exports of a country are given, and then here you see the diagram. On the basis of this example, with the help of this data, I am drawing this multiple bar diagram. Now here see, I have given here the color is, I denote this Orange color is your imports and green color is your exports. Okay, so now you see how we can draw, how we can code, how we can write in R. So what are the codings, what are the commands we are using here? Just you see, can you write by yourself? Because I have already given a simple bar diagram. Just you try to do in case of multiple bar diagram. Nothing different, but you see here, this is the general R command. This is the general R command. R, here you see data, then less than dash R bin. That means what is the meaning of this? This is the combines the rows, okay, all together. Combines the rows all together. So this is called your R bind. Okay. So here within the bracket, frequency 1 and frequency 2. What is this? I'm going to tell you. Bar plot. This is again multiple bar diagram. So that's why we are writing here bar plot. Within the bracket, you see data. So what are the data? That means what we are going to denote here, frequency 1 and frequency 2. Then names, dot argument, X lab, Y lab. These are same. Main, the title of the multiple bar diagram. And then color of the bars, border, everything is same here. Then this is we are considering T, then beside T means true. Okay, so we are considering here two, and then this you see listen. I have already told here one thing is here in your number 10, sorry, number 5, you see listen. This is the list of symbols. So here I am giving in case of multiple bar diagram list of symbols. That means what is imports and exports. This is called. Now you see, listen, this is position. Position means what? What is the position? I'm going to tell you. Then feel and then listen here. Now you see the command feature on the basis of our example. Okay, so this is the R command for drawing multiple bar diagram for the given data. So now you see import export. So our data is on imports and exports. So imports and exports we are going to show here as our multiple bar diagram. So we are writing here what are the imports and means and exports also we are writing here. So now see years. Okay, years is what? 2001 to up to 2006 we are writing. Then data. What is data? Import and export. So just you see in your general R command, R bind, this is frequency 1 and frequency 2. So this is your import and export. So data, then R bind, import and export. Okay, import and export. This is our frequency 1 and frequency 2. So bar plot, data. Data means we are considering import and export. Import and export already we denote. Okay, here we have written. So bar plot, data, then names dot argument. This is years because these are in years. It is given for 6 years. Okay, import and exports for the countries given for years, 6 years. And then X lab is here, we are considering here years. Okay, and in case of Y lab, we are considering import and export. Okay, so that's why in case of X lab, we are taking here years, and for Y lab, this is equal to your import and export. Okay, so color, this is we are choosing here orange and green. You can choose blue and red also, no problem. Then what is our main title? Multiple bar diagram. Okay, beside true. Then what is listen? Listen means position. Here I am writing top left. You can write also top right also, no problem. What is top left? Just you see here. That means this top and then left side we are taking. So this is the position of our listen. So imports and exports. Now you see here again. Then fill orange and green. So the color of the bars are orange and green here. Orange and green. Okay. So I think all of you understood. Then listen. This is equal to what we are considering imports and exports. This is we should give here. So listen, see, imports and exports, and also a box. Now you see, if we are putting this in our command, means we are writing, this is means I am copying from here and then paste in our window, but you have to type, you have to write the commands there. So this is, you see, we are getting this multiple bar diagram, okay, from 2001 to 2006, okay, for 6 years. So these are the commands. Then I am giving here one example, just to see what is the example. So second example is your, for you, this is a homework, because you have some sessions on your Sunday and Monday. So you please try on that day. These are the examples I'm giving for you to do as a homework. Don't worry, no need to show me, but you have any problem, then you can ask me. Now here you see what we are considering: following data for the outlay in the second and third 5-year plans. Represent the data by multiple bar diagram, nothing else. What we have considered in our first example, years, imports and exports. And here also given same thing, but here just it is given as heads. Okay, years as heads here. And so these are the heads: agriculture and community development, irrigation and power, villages and small industries, organized industries and minerals, like this. And then total expenditure, this is given in crores. So second plan and third plan. So these are the second and third 5-year plans, it is given. So we have to represent this data with the help of our multiple bar diagram. Same thing you do, but here what you are going to do here, in case of import, just you write here second plan and third plan. In case of your import and export, in this place you just write second and third plan. Then for years you write heads, and then you have to write all the names. Here I'm giving only the years 2001 to 2006, but you have to write the names of the heads: agriculture and community development, irrigation and power, all those things you need to write here. And then data, urban, import and export. In place of this, what we are going to write here, we are going to write second and third plan, okay, in place of import and export. So then what we are going to do next, everything is same here. In place of year, just you write heads. Then for X lab, this is heads, what you are going to write. Then Y lab, this will be import and export. So here what it will be second and third plan, okay. Then you choose color by yourself, and then you give the main title is your multiple bar diagram. And then what you take the listen top left. If you are going to take this in right side of this diagram, suppose imports and exports you are going to take here in right side of the diagram, then just you nothing to do, just you type here top right, okay, top right. Just you have to remember these commands, nothing else. And depending on the practice, when you are going to do more practice, then it will be more clear for you. Okay, so you have to practice it, otherwise it will not come in your mind. Just you try to do by yourself when you're giving your time. Then top right, fill, then color is by choose by yourself. Then listen, this you write second and third, nothing else. So I have already told you how we can write for this example. So this is very simple, you can do by yourself, just you practice at your home. Okay, so this is all about multiple bar diagram. Then next we are coming pie diagram. So pie diagram, we all know this is in circle. So this pie diagrams are 2-dimensional diagrams, and a pie diagram consists of a circle subdivided into several sectors or segments, we can say, by radius to illustrate numerical proportions. And the area of the sectors is proportional to the values of the components. And each sector represents a proportionate part of the whole. and the total value of the pi is always 100%. Okay, total value of the pi is always 100%. Now you see, this is pi diagram, how we can draw in our R program, R window. So pi diagrams are widely used for comparing relative contribution of the different components under a particular head. And these diagrams are commonly used in newspaper, magazines like this. So now you see, this is the example I have considered for you. So the following data gives the regions of petroleum in percentage for different regions. So now you see, we know this is in 100. Here I have given here pi is always 100%. So this is here you see this data is already given in percentage. That means the percentage values are given here. So the following data gives the regions of petroleum in percentage for different regions. So petroleum for these countries: America, Europe, Africa, Middle East, and then others. Okay, and these are the percentages. So on the basis of this example, this is the diagram how we can draw in R. So this is the diagram, and now you see, this is I have given here top right, so that's why these legends are coming in right side of the top. Okay, so now you see 13% for America. So here you see in red color 13% is for America. And you see, for Europe it is given percentage is 12. So this color light green color is your Europe. Okay, this is in 12%. And then Africa, you see, this is 9%. This is in green color. Dark green color, not dark green, but green color we can say. So this is 9%. And then Middle East, this is 61, the whole one. This blue one, this is 61%. This is petroleum for your Middle East country. And then others, this is in purple. Okay, so this is your others, this is the 5%. So on the basis of this, we know how to draw this pi diagram. So now you see the codings, the commands are commands how we can draw this pi diagram. Okay, so now you see, this is the general command for drawing our pi diagram. Just you write pi, then x. X means here you see petroleum percentage is given, so these are your x. Then labels, then main. Labels mean x lab, y lab. Here not we are using because pi diagram is your in a circle. So now you see how we can draw it. Main means the title of our diagram. So here we are giving pi diagram. So this is our main. And then color, then clockwise we are giving here. Otherwise it is anti-clockwise, so we are giving a clockwise, then it will take as a clockwise direction. So legend is here position, then field, then legend. So nothing else. So on the basis of this, just I am going to explain these things also, but first you see these things. So the R command for drawing pi diagram for the given data are x less than dash c, then within the bracket 13 to, these are the percentages which are given. So I'm telling this what I have to take petroleums for this country are this. Okay, so these are the x. And then you see labels is your the petroleum for those countries. Okay, so labels are your America, Europe, Africa, Middle East, and others. Okay, then par, PER. Par means you can write also here percent, PER, and because we are taking this as percentage, right? So we can write here PER or PERCENT, no problem. If you are writing here, if you write here percent, then you have to write here also percent here. Okay, so labels equal to percent. So labels we are considering here America to up to others, then percent or par less than this paste x comma this percentage symbol. Okay, so now you see pi x levels, this is equal to par Per means this one. Then main, petroleum, or here you see in the diagram I am writing here petroleum, but you can write here if you want to give, this is pie diagram, then give colon and then petroleum. Then just here what we have to change here, just in main, just you give here pie diagram, then colon your petroleum, okay, or pie diagram on petroleum, you can write like this. Okay, here I am giving only petroleum, so you can write here pie diagram and on petroleum, you can write like this. And then color, rainbow, I am giving a rainbow color, so length is your x means this, okay. So clockwise, that means true, T for true, it means true. Then legend is white, what, top right means I have told this one, America, this is in top side, right side, in the top. Then C for America, this all these things, that means the labels you write here. And then CEX, I have already told what is this, so I think I have told about this CEX, okay. So fill, rainbow color, then length x, then within the box. Now you see, with the help of this example, the R command for this example is these things, these commands. These are the commands for this example. And now you see, this is the result. Okay, and then now you see here I'm writing, if the argument x is not expressed in percentages but in terms of absolute values, because here in this example it is given in percentage, so that's why we are not writing anything here in our R command. But if the argument x is not expressed in percentages, means these values are not in percentages, then what we'll do, but in terms of absolute value, just only values are given, but those are in not in a in percentages, so it can be converted to percentage using the following command. Okay, so we can convert those values to percentage and then we can write. Okay, so how we can convert this those values to percentage, just you write here, you see in this command we are writing only par, then paste, only just paste, then the values of this x in percentage it is given, so that's why it is only given the percentage symbol. But here what we have to do, just you write round, then within the bracket you write 100 to x, then divided by sum x, then comma 1. Okay, this is the command, just try to remember this command when the values, means the arguments are not given in percentages. In that case we are using this command. Okay, so please remember this command. And here this one is what, one indicates that the percentage is rounded correct up to 1 decimal place, only for 1 decimal place, so that's why we are writing here 1. Okay, so this is the command, just try to remember. So this is all about pie diagram, and here I am giving one example for you also. Don't worry, I'm giving examples and examples on this, but don't worry, you just try at your home for your help. I'm giving, it will be helpful for you also. So the tax revenue of India in crores of rupees as provided in 1984 to 85 budget, when broken into various sources, are given below. So you just represent this data with the help of your pie diagram. So sources are given, tax revenue, just you try to do by yourself. It's not, I think, not given in percentages. So what we have to do, just you think and try to do, because I have given all the commands here. General command is given, then when values are arguments are in not percentages, then which command we are using, then I have given. So just think and try to do what is this. Okay, this example number 2 for pie diagram is for you. Okay, so as a homework. Then histogram. So what is histogram? One of the most commonly used method of presenting frequency distribution of a continuous variable, which is known as histogram. In drawing a histogram, X-axis is used for representing the class intervals. Class intervals means suppose it is given 0 to 10, 10 to 20, then 20 to 30, like that. So, and y-axis is for our frequencies. On the basis of class intervals, it is given some frequencies, then we can draw histogram. And the histogram consists of a series of rectangles. This is a series of rectangles attached to one another. Attached to one another, that means what? One rectangle is used for each class. The height of each rectangle is proportional to the frequency of the corresponding class. I think all of you understood. Here, one rectangle is used for each class. That means suppose it is given 0 to 10, 10 to 20, like that. So for one class 0 to 10, so one rectangle is used for only one class. Okay. And the heights of each rectangle, which is proportional to the frequency of the corresponding class. Suppose for 0 to 10, it is given 2. Then the rectangle is only for this class and the frequency is 2. And the weight of the rectangles, which varies depending on the distance between the class boundaries. Okay, weight of the rectangles, that means what? Just you see this. These are the rectangles, and the white means the difference from here. Okay, from first rectangle, second rectangle, this. Okay, so here all are same, but now you see what I'm telling. The weight of the rectangles varies depending on the distance between the class boundaries, and so they need not be equal. Okay, it may be here in this diagram, it is equal. All the rectangles are equal, but in sometimes suppose here it is given 10 to 20. And then 20 to 40, then second one will be suppose 20 to 40 up to this. So two rectangles will be taken. Okay, so here it is given that the class boundaries depending on the distance between the class boundaries, and so they need not be equal. So unlike a bar chart, there is no gaps. In bar chart, you have seen here for our bar chart, here you see there is some gap for each bar. Okay, but in case of your histogram, there is no gaps. Okay, so now you see unlike a bar chart, there is no gaps between the bars in a histogram, because it is used to represent continuous data, because data is continuous in case of histogram. So that's why there is no gaps. Okay, there is no gaps. So now you see the example number 1, a frequency distribution of wages of a group of employees. So here it is given. So with the help of this data, just you represent this histogram. Okay, so 10 to 20, 20 to 30, 3, 4, 5, 6, 6 classes, class intervals it is given here, and then the number of employees. That means the frequencies are given here. So how we can draw? This is your general command for drawing histogram. So just I'm telling in my first second or third slide, I have given all those. So HIST, that this means histogram. So here you write the HIST, then data. So what is given, suppose mean from example we have to take, and then main title of the histogram, then XLab, variable name, YLab, frequency. That means what is in XLab and levels of X and levels of Y. Just you give by yourself, and then border, color of the bar borders. And then color of the bars, then X lim, that means limits, C from and to, and Y lim, this is also from and to, then LAS, last, then breaks. So just you think, we are not using all those things, just only with the help of this example, our command is X is what? Your 10 to 20, then 20 to 30, up to 60 to 70. And what is our Y? Just you see 8 to up to 5. Okay, so 8, 10, 16, up to 5. Then just you write bar plot, then Y, this is space equal to 0, we can write. Okay, then names, argument, this is X, XLab, this is wages in rupees, then color is your orange. We are considering here orange color. Then Y lab, this is number of employees. Main is your histogram, then box. Okay. So now you see, this is your histogram. Y means what? Here Y is your number of employees. Okay, means the frequencies. And here wages in rupees, these are your in x-axis. Okay, so this is the class intervals: 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, then 60 to 70. So this is your histogram. And now you see, this is example, represent the following data in the form of histogram. This is for you also. Just you take the marks and number of students. This is the same thing I have given here for practice. And next one is your line diagram. What is this line diagram? The line diagram is generally used in statistics to represent time series data. And with the help of line diagram, one can know how successive values of the variable are related to specified point of time. Okay, so now you see, here we are considering again one example for line diagram. Suppose we have the following data on the amount of rainfall in millimeter in a place for first 5 months of a year. Months we are considering 1 to up to 5. Amount of rainfall, this is given 9 to up to 45. And here you see, this is the line diagram. Okay, how we can draw this line diagram in our, and here this side months we are considering 1 to up to 5, and in y-axis there's just, you see, this is your rainfall. Okay, amount of rainfall. And now for line diagram, just you see, plot rainfall for this example. Plot V type, call COL, XLab, YLab, main, then LTY, LWT, line type, line beat. Okay, so here you just see the command rainfall, then this less than dash C, 9 to up to 45. These are the amount of rainfall, 9 to 45. So we are writing here 9 to up to 45. Then just to write plot rainfall. Okay, rainfall for this data is on the basis of rainfall, amount of rainfall. So here we are write the name. Okay, then type O. Here you see, this is O type. Then color is red. So this is in red color. This is in red color. And then XLab, this is, you know, month, and YLab, rainfall in millimeter. Then main, this is line diagram, or we can say within the bracket I'm writing here. This is depends on you what you want to give the name of the diagram. So just you give by yourself, line within the bracket rainfall diagram. Then I am giving here box. So this is within the diagram, is within the box. Okay, this is your line diagram. This is very simple. It is coming here, line within the bracket rainfall. If you give only line diagram, if you give here only line diagram, then this is also okay. Then next you see example number 2. Following data sorry, following data gives the population of Assam in thousands in the various census years. So represent the data by line diagram. So this is these are given here years, then population. Okay, so you have to represent this data with the help of line diagram. So now you see the last one, scatter diagram. So what is this? This is very interesting. Scatter diagrams are types of graphs that helps us to find out if two things are connected. I think line diagrams are clear, because this is very simple. If you have any confusion, then you can ask me, but these are very simple. That's why I'm going fast about this line diagram. And then you see scatter diagram. So what is this? Scatter diagrams are types of graphs that helps us to find out if two things are connected. Okay, And with the help of scatter diagram, we can study the nature of relationship between the two variables in a data set. So this is the main thing for scatter diagram. With the help of this diagram, we can study the nature of the relationship between the two variables, okay, in a given data set. So this is example I have considered. Following data gives the price of carpet in rupees and size of carpet in square feet in a shop. Okay, so these are the price and these are the sizes in square feet. It is given, okay, for carpet. So now you see how we can draw this scatter diagram. So price, it is given, this is price in rupees and then size in square feet. So here the price and then price of the carpet, and then here these are the size of the carpet. So this is in square feet. So first scatter diagram I am drawing here, scatter diagram of price along x-axis and square feet along the y-axis. Okay, so this is your scatter plot one. That means this is the scatter diagram for price of carpet in x-axis, and in y-axis we have taken here size of carpet. So now you see how we can draw plot price. Price is this, and then square feet, the size of the carpet. Then main, I have given your name as scatter plot one. Scatter plot one. Then x lab, we are considering price of carpet in rupees. And then level of y I have considered here size of carpet in square feet. And then PCS, what is PCS? Plot character. I have considered here 15. So what is this? Now you see, this is the diagram on the basis of this command. These are the R commands for this scatter plot number one. So these are the plot character. This is PCS equal to, that means plot character I have considered here 15. So this is look like as in square box, fill square box. Okay, solid square box we can say. Now this is your scatter plot one. So I think this is understood. Now you see the second one, price and square feet, size of the carpet and price of the carpets are there, and to change the color of the plotted points. So here we are drawing here the points are in black color. Now we are going to change this plot color by red. Suppose this, okay, these are in red color. Now you see how we can do this. Same thing, plot price square feet, color here is red. Then scatter plot 2, I am giving the name of the plot is scatter plot number 2. Then levels of y, x and y, here it is given, and then we have considered plot character is your 19. So this is your scatter plot number 2. This is very simple. We can do. Then you see again what we have done here. Takes, these are all R commands. Here also for this number 2, these are R commands, and for this is number 1, these are your R commands. And number 3 means here I am considering scatter plot number 2, but here you see text. Text means what? Just you see the diagram. I think all of you have seen this one. Scatter plot 2. I am giving a scatter plot 2. Just you give 3, 4, no problem. This depends on you. And here you see I have this is in a line, and then here you see these are the numbers. Numbers means the size of the and price of the carpets, and here in green color, and then here in blue color. Okay, so which are green, which are blue, just you can give here the legend. I have not given here, I have not added here the legend, but you can add here. I have already told how we can give a legend. So it depends on you, you want to give or not. So now you see text, price, square feet, labels, price, color, blue. Okay, then adjust adjusted, this is 0.5, pause, this is 2, pos means position, and then CEX6. Okay, so this is the symbol size 0.5 I have taken. And to add data levels of the variable price, to add data levels, that means data levels of the variable price. For price I have taken the variable. Okay, now you see again text. This is price, square feet, level, square feet. So we are taking text. I am writing here text. Okay, that means for price, so price is your 1800, 1890, like that. So it is in this diagram, the all the values are here, all are price. Okay, and for square feet, just you see, just you write text and then price, then square feet, labels, color. Here I have considered green. So you see in the diagram, this is in green color. So these are all square feet. That means the size of the carpet. And then to add data levels of the variable square feet. For first one is for to add data levels of the variable price, and to add data levels of the variable square feet. And now lines. Lines means what? This cell connect the point by lines. So no need to write these things. Okay, I am giving here as then to add data levels of the variable price, to add data levels of the variable square feet, and this cell connect the point by lines. No need to write in R command. Just only you write lines, price, comma, square feet, up to this. This is only for you to know what is this, what we are doing. Means lines means it is, you see in the diagram again, here lines are coming. This line is here. So this is coming. This is your command, R command, lines, then within the bracket, price, comma, square feet. Okay, so this cell connect the point by lines. Okay, so this is all about on this diagram. Okay, I think all of you have clear. If you have any query, then you can ask me. Okay, then next you see, suppose we want to include the names of shops from which the carpets are sold instead of the data levels. Okay, that means what? These are the data levels. Our question is what? Our question is this data gives the price of and size of carpet in a shop. So suppose we are not considering these data levels, this data, we are just want to know the name of the shops from where we can buy this carpets. Okay, so we want to know only the shop names. Okay, so here I'm giving, that's why I'm writing here. Suppose we want to know, we want to include the names of shops from which the carpets are sold instead of the data level. So price and square feet is there. Now you see, suppose I'm considering just nothing else, just I'm giving example, nothing else. So shop is what? Lakshmi, Vishal, Big Bazaar, Metro Bazaar, V2, City Card, Bazaar India, Reliance, Metro Bazaar, Vishal, Big Bazaar. I'm repeating here. No problem. Just you give by your choice. Give Big Bazaar, then City Card again. Okay. So now you see how we can draw this. This is the diagram on this. Here only the here what is coming here. Here only the names of the shops. Okay, not with the help of data. Means we are not considering here data levels. Only here I'm considering the name of the shops. So how we can draw? What is the command? What are the commands? This is in red color. You see the points are red color. Then main, just I'm giving your names for this scatter plot 2, and then X lab means the levels of X. Here also same, price of carpet in rupees, and for level of Y, this is also size of carpet in square feet, and plot character we are considering here 19. Okay, so this is our command. So text, just because here we need only, we are going to write only the names of the shops, so that's why I'm writing here text, then price, square feet, labels. Labels equal to what? Labels means we are giving the name of name, or what is the level of the level of our means the data levels we are not considering, only the name of the shops we are considering. So labels we have to give as a shop. Okay, so earlier one, what we have done here, you see labels square feet, and here labels price, means we are considering the data level, datas only. So, and in this example, last one, I am considering here labels are your shop. Okay, and then adjusted 1, position 2, then 6, this is equal to 0.5. So this is what, no need to write this thing, get the shop name in the left side of the dot. Okay, so no need to write this thing, this is only for you. So just R command is only from here, shop to up to this, within up to this bracket. Okay, this is your R command, just to get the shop name in the left side of the dot. Now you see we are getting this. First one is Lakshmi, and then this is Bisal, Big Bazaar, Metro Bazaar, like this it is coming. So this is scatter plot I have drawn on the basis of the shop name. Okay, so what we have done in our scatter plot, this is the example. First, in first example, what we have drawn, only the plot, the data levels I have given only the in our first scatter plot, and for the second one, so we just change our color of the dots. Okay, and then third one, what we have done here, dots are there, just we are giving the data level here only for both price and square feet, means price and size of the carpets. And then the last one, what we have done here, only we have done we learned how to give the names of the shops in this scatter plot. Okay, so this is all about scatter plot, and I have completed all those things what I have considered in today's presentation in as my objectives. So up to this we can we know how we can draw different types of graphs, different types of diagrams. So simple bar diagram, multiple bar diagram, then histogram, pie diagram, line diagram, and then scatter diagram. So this is all about today's class. And just I told you earlier about the subdivided bar diagram. Okay, so just nothing else I have not included here. This is also simple. We can do these things with the help of what I have done here in case of multiple bar diagram. So just you see what is multiple bar diagram, how we can what are the commands for our multiple bar diagram, and everything I have explained means what is needed in your R commands. So everything means all I have covered. So with the help of these things, I hope all of you can do your exercises, means what I have given here, and also I include in last is your subdivided bar diagram. Okay, so my why I have taking this in last, that means this is as your homework you have to do, and just you study these things thoroughly, and then you can do it, and you try by yourself. Subdivided bar diagram you just see from book, and you take help from Google also, no problem. Just try to do this subdivided bar diagram. Just I'm going to tell you what is subdivided bar diagram. Simple bar diagram we know, multiple we know, and then what is subdivided? Subdivided, that means you understand. Divided means you understand the word. So sometimes what happen, it is necessary to show breakup of one variable. Okay, breakup of one variable into several components. For this, we are using subdivided bar diagram. So a simple bar diagram is not useful in such situations because we are not able to do we are not able to show the breakup of one variable into several components with the help of our simple bar diagram. So in this case, we are using our subdivided or we can say component bar diagram, which may be used to represent data relating to such a variable over time or space. Okay, so in case of simple bar diagram, bars, or we can say bars, we can say rectangles. Okay, bars are also called rectangles. So in case of a simple bar diagram, bars are drawn to represent total magnitude of the variable, and each bar representing one category only. But in case of subdivided bar plot or bar diagram, this bar is divided into segments. Okay, and each segment representing a component of the corresponding category. Okay, so what is our subdivided bar plot? This bar is divided into segments, each segment representing a component of the corresponding category. So that's why we are using our subdivided bar diagram. So here you see, I'm giving one example here for you. Okay, this is subdivided bar diagram. So just you write what is subdivided bar diagram. This is you can find out from books. Okay, from higher secondary level statistics books or degree level, you can find out. And then this is example. This table shows the number of students in different faculties of a university. Then this represent the data, this data as a subdivided bar plot. So I have given here only for this year, you have to show within this bar. Means for, suppose you see here we are considering year 2001 to up to 2005. Okay, so for this year just you have to show humanities, science and commerce. So what is given here? Number of students. Okay, number of students for humanity or science or commerce. So in 2001, how many students are in humanity? 2810. For science 890, commerce 540. In a single bar, just you have to show within the single bar for only for 2001, only 1 year. Okay, so here you see our simple bar diagram is. Okay, here just you see we didn't, suppose this is 2011 and there is we are considering suppose 2001. So in this simple bar, one rectangle, just you have to divide it humanity, then science and commerce. Just you have to divide this simple bar diagram. Okay, it's not simple bar diagram, sorry, subdivided bar diagram. That means you just divide one rectangle within the corresponding year. Okay, so here it is given for your 2001 to up to 2000. Just to see, 2001 to 2005. So for 2001, you have to, that means 1, 2, 3, 4, 5. 5 rectangles will be there in your diagram. And then for 2001, just you divide 2000, humanities, science and commerce students. For 2002, again, you divide humanities, science and commerce students. And similarly, up to 2005, you draw the graph within the within one rectangle. Okay, just you have to you have to divide this thing. This is called your subdivided bar diagram. This is very simple, just you try it. Okay, this is for you, and just you write what is subdivided bar diagram, and then this is the example. With the help of this example, you represent the data as your subdivided bar diagram or bar plot. Okay, so this is all about today's presentation. Thank you. If any query, then you can ask me. Hope all of you understood. I have taken very simple things here to understand all for you.
Thank you,
So
ma'am.
thank you all.
Thank you, ma'am,
Thank you, ma'am. It
for
was very simple and elementary session, so
yeah.
it was
Thank you, ma'am,
very
for
nice.
sharing your knowledge in such a simple and lucid way. So that means we are getting lots of things from this presentation. I think each and every student should be benefited from this presentation. So
Thank
now,
you. It's my pleasure.
pleasure. That means we are eagerly waiting for another session. So if you have any time, so we are going to meet you in the future. I think each and every student gets something from this lecture. It is an awesome, I think so. So now it's open to each and every student so that you may ask any question, any doubt, any queries to ma'am. So she will give you definitely the answer. Any queries, please. If you understand, then you have to ask the question. So everyone, I think you are getting something from this lecture. Please ask if you have any doubt, any queries.
No queries
Maybe
as of now, sir, but we may post it in the WhatsApp group if they're after practicing the things.
Yeah, you don't have any question. Okay, so that means you can discuss in the WhatsApp group, and if you want to contact ma'am, so you can contact directly. She will
okay, no
definitely
problem.
help you. Yeah.
Because they have to do some practice. After that, their query will come. Okay,
Yes.
so that's why it's okay, no problem. You can ask me through WhatsApp group. So
Mm.
thank you all.
Thank you, ma'am, for your wonderful, awesome lecture. Thank you, ma'am.
Okay, thank
Okay,
you.
then.
Thank you,
Bye.
ma'am. Thank you, sir.
Okay, bye.
Thank you. Bye. See you again. That means all the participants should be joined in the next session at 1:30. So that means that in that session, we are going to discuss about the GeoGebra. Thank you, everyone. Bye.
Okay, bye.
Mhm.
Good to see.